Yeah, welcome back to the lecture series of Java programming. So today we are going to see the first part of this image, that is set 3. So we'll talk about how to solve question number 11 to 15 and we'll close the class. Okay, though it takes some time, so you have to patiently listen to the subject. Okay, now what is the first program? The first program is to check if a number is prime. Okay, so here let me explain you first what is prime number. Okay, now a prime number is a natural number. It is a natural number greater than 1 that has exactly two distinct positive divisors. Okay, so this is the first point. Okay, so the first one is 1, the second one is itself. So this is the first point you have to understand, right? A number which is divided by 1 and itself, simple. A number which is divisible by 1 and itself, then it is called as a prime number. So some examples are like this. 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 is a prime number, right? Now the numbers which are not prime are called as composite numbers. The numbers which are not prime are called as composite numbers, right? I'll tell you one example here. Example is like this: 4. Okay, so 4 is divisible by 1, 2, 4. Okay, so 1 and itself only is the definition of prime number, but here composite number is divisible by 1 and itself and also 2. 6, which is divisible by 1, 2, 3, 6. So in this way you have to understand the difference between prime number and composite number. Alright, now based upon this we have one more thing. 2 is not a is only even prime. That means even number which is a prime. 2, right? And 1 is not a prime. 1 is not a prime because it has only one divisor. Okay, that is itself. Okay, so keeping all these things in mind, you now start writing the programming for finding a number as prime or not. Okay, so keeping all these things in mind, right? Now we'll go with the coding part. Now see here, import java.util.scanner. Done. Then class a name to be given to check prime. Check prime. Okay, public static void main string arguments scanner sc equal new scanner system dot in. Okay, now we want to define a number int num. Okay, through this only we are going to give the input as one number and to check whether the given number is prime or not. For that, system dot out dot println enter a number. Okay, then number is equal to sc dot next int. Okay, then see here, now what we are doing to what we are trying to do, we are trying to check the number. If yes, it's a prime number. If no, it's not a prime number. So we have only two options from which we have to choose one, and for that we will take a data type boolean. Boolean is prime true. Okay, now we'll check. The logic starts from here. If number, what the number we have taken is less than or equal to 1, okay, is prime is equal to false. Okay, else for int I is equal to 2, I less than num less than or equal to number by 2 I plus plus. Okay, in this we have one more logic. If number mod I is equal to 0 is prime equal to false. Break. If I'll explain you all the program. If is prime, system dot out dot println number is a prime number. Else is not a prime number. Now see here, first let us check that whether the open number of open braces equal to open number of closed number of open braces. Okay, so that you check. Then this line you know, this line you know, this line you know, this line you know, this line you know. Okay, this line we are declaring a number here, a number to be taken as input. So this line you know, we are asking the user, this line you know. From here the actual logic starts. Now see here, now we are defining a variable and naming it as a boolean variable. That means it will have only two values, one is true value, one is false value. Okay, now from the condition we have discussed in the previous few minutes before this writing program, a number which is less than or equal to 1 is not a prime. So straight away, based upon that condition, we are printing this is not a prime. Is prime is false means it is not a prime. If this case is not valid, then you have to go to the next part where this is to be taken into consideration. Okay, now see here. Now for I is equal to 2, I less than or equal to number by 2, I plus plus. Right, now number mod I is equal to 0, then it is said to be false. So for this logic we will try to understand with the help of an example. I'll copy this here in order to make you understand better. Now see here. Now I is equal to 2, right? I is equal to 2, I is equal to 2. Okay, then I less than or equal to number by 2. I, what is I? 2. Less than or equal to, let us suppose that 3 is the number by 2. Okay, okay, if this condition is okay, then we can go with the proofing of whether it is a prime number or not. I is equal to 2, I is less than or equal to number. What is number here we have taken? Suppose n is equal to 3, number is equal to 3 we have taken. Okay, then I plus plus, so 2 will get increments if this condition satisfies. What is this condition? 2 less than or equal to 3 by 2. 2, now see here, 2 less than or equal to, what is 3 by 2? 1.5. okay, so which is not at all possible. Okay, so here 3 is, what is 3? 3 is a prime number. See here. So if this condition satisfies, then we are telling that it is not a prime number. So here 3 is not satisfying this condition. 3 is not satisfying this condition. So is prime will become false. Is prime will become false. Okay. Now if not, we take here 4. Okay, I is equal to 4. Wait, I, what is I? 2 less than or equal to 4 by 2. Okay, then which is nothing but 2 here. 2 here. 2 less than or equal to 2. Okay, then what happens? Then this condition comes. This condition comes. This condition tells that it should be exactly divisible by 2. Okay, now 4 mod 2 is equal to 0. Okay, so then for the condition is satisfying when we are taking n is equal to 4, so is false. That means n is equal to 4 is not a prime number. Okay, right? Now 3, when n is equal to 3, it is a prime number. This condition is not satisfied. When n is equal to 5, again same. So in this way you have to trace out. Okay, so now see here. Now I'll save it, copy it, save as, I'll save it here. Okay, come here, Java C, now see here, cannot find a symbol. Why? Because somewhere you have written is prime in which P is capital, here it is small. Okay, now save it again, just save it. Now come here, now again it is giving as an error. Okay, cannot find a symbol. This should be true. In which line it is giving error? 22, line number 22. Just a minute. This is the spelling mistake. Okay, I'm saving this. Save this. Come here. Now see here, Java Now enter a number. Suppose it is 2. 2 is a prime number. Suppose I enter 4. 4 is not a prime number. So this is the logic. Simple logic. Try to understand. Okay. Now we'll go with the second program. What is the second program here in set 3? Find the factorial of a given number. Find the factorial of a given number. Factorial of a given number. So for that, what I will do is I will go with the program like this. You know what is the factorial? Okay. So factorial 2 factorial 2 into 1, 3 factorial 3 into 2 into 1, 4 factorial 4 into 3 into 2 into 1. So in this way you have to understand the logic. So for that I am writing the program like this: import java dot util dot scanner. Okay, then the class factorial. Okay, public static void main string arguments. Okay, scanner is C is equal to new scanner system dot in. Okay, then we have to take some number here, int number. Okay, system dot out dot println enter a number. And is equal to sc dot next int fact is equal to 1. Right? Why? Because count starts from 1. We are taking fact is equal to 1. Now for int I is equal to 1, I less than or equal to num I plus fact is equal to fact into 1. Okay, now we are going with the output statement: system dot out dot println factorial of is fact. So we'll go with the execution part now. So the execution is like this. So let me save this. Java C factorial dot Java. There are some errors here again. We'll see what are the errors. The last line only we are seeing some errors here. System dot out dot println factorial. Now here we need to have some plus symbol. I'm saving this. Again we do have some errors here. Let me check again. System dot out dot println factorial of plus num We should not give any gap here, I think. Now save it. Come here. Factorial. Let's see how I'm doing this. Right. Let me save this. Execute here. We have one more error. Somewhere we have not given the end statement here. Semicolon. Now save it here. Execute this here. Now it is 2. 2 factorial on 2 into 1. 3. This output is coming only because we have written error here. So this is I here. Okay, not 1. Okay, now we will execute. Two factorial is 2 into 1. Okay, 2. 3 factorial is 3 into 2 into 1 is 6. 4 factorial is 4 into 3 into 2 into 1 is 24. So this is how you have to understand, right? So we'll go with one more program. Multiplication table. A simple program for mathematicians, but still we'll try to understand what it is. Okay. Import java util scanner plus table. Okay, m table, multiplication table. Public static void main string arguments. Scanner is C is equal to new scanner system.in. Okay, now we will write from declaration into number. We are taking one number here. So system dot out dot println enter the number. Okay, already as we have declared that variable, no need of declaring again, is equal to sc dot next int. Okay, for int I is equal to 1, I less than or equal to 10, I plus system dot out dot println now see here number plus x plus I plus C. Just pause the video and see how I am writing. Num plus x plus I plus is equal to, okay, right, we'll get this without any error now. Okay, just save it, copy it, save as. If we have any error, we will rectify. There is no issue. Java. No, we do not have any error. Suppose I write 2, then this is the formula. Now see here, we are again getting some error here. 2 into 1 is equal to 2 into 2 is again 2. So that for that we have to rectify here. Every time we are facing this one I, it should be I. Okay. Now 2 table. We will get the second table. Okay. Suppose we are going with 3. We will get 3 table. Okay. So this is how we are going to solve the 13th one. Generate a multiplication table. Now we'll go with checking with the leap year. Okay. So the logic here he has given is like this. Here that is leap year if it is divisible by 4 but not divisible by 100 unless also divisible by 40. That means simple, divisible by 4 and divisible by 400 but not divisible by 100. One sentence logic, one statement logic, so we'll go with that. Okay. Import java.util.scanner plus leap year public static void main string arguments scanner sc is equal to scanner system.n. Okay. Now we have to take one number here. Okay, int var. Okay. Now system dot out println enter the year. Okay, in year is equal to sc dot next int okay. Now the condition, what is the condition? Simple condition. Okay, if y is exact divisible by 2, exact divisible by 4, and at the same time it should not be exactly divisible by 100. Okay. Okay, but it can be divisible by 400. Okay, then you can print it. System dot out dot println here leap year else system without println here is not leap year. Okay, so this is the coding. Only this is the logic you have to understand. A number which is exactly divisible by 4 but not exactly divisible by 100 but again exactly divisible by 400 is called a leap year. We'll see. We'll save this. If any mistake again, we'll clarify. We'll solve. Just save it. Come here. We do not have any error here. We are executing it. 200,000 is a leap year. (2025) is not a leap year. Okay, so this is the way you have to execute the code. Okay, now the last program in this class, then we will try to stop. Reversing of a number. Okay, extract digits using mod 10. Build reversed number using multiplication and addition. Simple logic. For this we have to develop the code. Right, now the code is like this. Import java.util.scanner class reverse number, public static void main string arguments. Okay, scanner sc new scanner system.in. Okay, then we have to take one number, right? Into number. Okay, now we have to read this statement system.out.println enter a number. Okay, then number is equal to sc.next int. So when we are trying to reverse a number, the number count will start from 0. For that, reversing is equal to 0. Okay, now the actual logic, while n not equal to 0, this first we have to check. If it is not equal to 0 or less than 0, then we need not to reverse a number. Okay, int digit is equal to number mod 10. What you will do, you will take a paper, you will try to execute each and every step once in a while to understand whether the writing code is correct or not. 10 plus digit. Reverse number. So this is the code. So what I will do, we will save it, copy it, save as, I have saved this. Now come to this part, we will execute this. Some error is there again. So see here, this part is to be cleared. Save it. Must again execute. Again we have one more here. Now this is need not to be. Save it. Execute this. Now we have not declared n here anywhere, so what we will do is we'll go with this one. Okay, copy this, paste here, now save here, now execute. Now we don't get any error. Java C or n, enter number 123, the reverse is C21, and this works for any number, any length number. Okay, 8985888777. now this one is problem. See here, the integer can handle only a number up to certain limit. So the question for you is to find out up to which limit the integer can handle. Okay, so keeping it that is a Viva question for you. Up to 30,000 only it can handle. Okay, so this is all about the programs. So hope you have understood the coding today. So we'll talk more on this content on in the day after tomorrow's video lecture. Okay, so day by day, and on every alternate day I will try to give the video lectures on the coding by showing you how they are being written. Okay, so this is all about today's program. Thank you.